Test 1 will be next week, which is October the 8th. October the 8th. I will remind you again, of course, on Tuesday. But the test 1, last time I said it maybe go up to 1.7. And then when I check my spring 19 test 1, it's only up to 1.6. So yes, it's not including inequalities, up to equations only. Okay, and spring 19 math 245 test 1 file already uploaded on my website, not on Canvas, but on my website. So you can take a look. If you wonder where's my website, look at my syllabus. Okay, now last time we did finish up the linear inequality from 1.7. Today we'll continue with the absolute value inequality. Now in this absolute value inequality, there are two type of inequalities we need to be aware of. The first one is the absolute value of blah less than or less than equal to a positive number c. Maybe I say for c a positive number, if you have absolute value of blah less than or less than equals to a positive number, that implies the next step you do will be that blah is between negative c and positive c. If it has equal sign, then you use equal sign. Now, of course, you may wonder why you do that. Well, because this expression, absolute of blah less than c, for example, means all those x all those blah, to be more precise, whose distance from 0 is less than c. Because it's less than c here, it's less than c. Okay, but when we look at the number line, and let's say this is 0, okay, now when we say the distance from less than c means the distance to the right and the distance to the left. All those blah whose distance from 0 is less than c. Okay, so the blah can be anywhere on this interval here. Okay, the blah can be anywhere in this interval. Now it means the blah must be greater than negative c, less than c. Now of course, like what I said before, if this have equal sign, then this has equal sign, and this becomes a bracket instead. Okay, if the distance is less than c, means at most c to the right, less than c to the right, and less than c to the left. Now try to imagine this picture here, the diagram, okay, the number line, such that you have idea how do you come up with this. Now the reason I tell you to imagine the diagram is because of the following. You have two cases that are very, very similar. The first one is less than equals to, the second one is greater equals to a positive number. Now, if that's the case, then this blah, either this blah is to the left of negative c or to the right of positive c. Now, in case you wonder why, the same explanation we have earlier, because absolute of blah greater than C means the distance of blah from 0 should be more than C. Okay, if we have equal sign, then it will be more than or equal to. Now on the number line, when we try to picture that, let's say this is 0 and this is the number line for blah. Okay, now the blah that is more than C units from 0 should be located to the right of C or to the left of negative C. Right? So in other words, if you pick any numbers here, let's say the distance from this point to 0 is more than C. Okay, the distance from this point here to 0 is more than C. Now we are interested to find the interval at which the distance of the guy inside the absolute value is more than or equal to C. So if we have equal sign, then we use bracket instead. Okay, therefore it's the blah is either to the left of negative C or the blah is to the right of positive C with equal sign if the original absolute value inequality have equal sign. So we do it with some understanding first. Okay, then if we look at our textbook, let's say for example number 60. Number 60, we have absolute of x over 5 is greater than 3. No? The other side is, the absolute value is isolated, and the other side is positive constant, a positive number. Then either the blah is to the left of negative 3, because the distance has to be more than 3 from 0, right? But when you say the distance more than 3, it could be more than 3 units to the right or more than 3 units to the left. Now, this is the first case here, is more than 3 units to the left. Okay? Or the blah is more than 3 units to the right. Now then, from here I solve it, multiply by 5, multiply by 5. So in interval notation, the solution will be negative infinity to negative 15 parentheses union 15 to infinity. Okay. Number 62. Absolute value of x minus 7 is less than negative 5. But hold on, we have some red light here. This is a negative number. That's a negative number. Is it possible an absolute value to be negative? Or even less than negative 5? That's impossible, right? So that's why when the constant on the other side is negative number, then we treat it with some little logic, okay? But from here we see, oh, it's impossible. No solution. And you may want to explain a little bit, because absolute of x minus 7 will be greater equals to 0 for any c, for any x. Okay, it won't be negative. Okay, number 64. absolute of x minus 8 greater equals to 0. Notice that the other side is not positive number. That's a 0. That's not positive. So you think about that a little bit. Okay, you think about that a little bit. Is it possible that this is not right? The fact is, whatever the x, the distance will always be greater or equals to 0 for whatever x. In other words, this is always true. Always true. Right? That's always true. While this one, this is always wrong. Okay, now if we have always true, which we call identity, then the solution will be all real numbers. Or you can say from negative infinity to infinity. So number 62 and 64, I'm actually dealing with the type of questions that not in my earlier explanation. But let me explain that a bit further. Suppose I change the problem on number 62. I change it to the absolute of x minus 7 greater than negative 5. What will your solution be? Is it always true or always wrong? Nobody say anything? That's always true, right? Now, because that's always true, then the solution will be all real numbers. Okay. Now, number 64, I go back a little bit. How about absolute of x minus 8 is greater than 0? Is this always true? Is this always true? That's right, not at 0, that's right. Always true except always true except at 0. Okay, so basically this is always true except when x minus 8 is not equals to 0. Is it right? Okay, or x is not equals to 8. So the solution will be all real numbers except 8. Or if you write it in the the true interval notation, that would be negative infinity up to 8, parentheses, union 8 to infinity. Right? Number line wise is everything except 8. Okay, so this type of question, if the other side is not positive number, like 0 or negative numbers, then you need to wear your thinking cap because it's more about conceptual problem instead of computational problem. Okay, now let me go on. Number 66. Absolute of 1 minus 2x to be less than 5. So is this the first type or second type? If we look back here, this is the first type. This is the second type. Okay. In the interior for the first type, in the exterior for the second type. So is this the first one or the second one? interior or exterior? The first one, it's inside. So this guy, 1 minus 2x, is between -5 and 5. And then from there, you solve it as usual. -6 less than -2x less than 4. And then I will divide by -2. But because we divide by negative number, reverse the inequality sign. And so there should be +3. Okay, which if I write it in the order that we get used to, then x is greater than -2 but less than 3. The solution in interval notation will be -2. Okay, now always isolate the absolute value first. Always isolate the absolute value first before you work on that. Like number 70, absolute of x plus 14 plus 3 is greater than 17. So isolate the absolute value first. Okay, and then you see, oh, is it type 1 or type 2? Interior or exterior? That would be exterior, right? So x plus 14 less than -14, or x plus 14 greater than 14. So x is less than -28, or x is greater than 0. In interval notation, that's -infinity to -0.8 union from 0 to infinity. Okay. Let's check. Oh, what? 17. No. Because I subtract by 3. Remember, I subtract by 3. Right? Okay. I need to isolate the absolute value. Okay, that's for this little part here. Suggested homework from this 1.7b will be number 57 to number 81. But just do it, maybe I would say it this way. Number 57 to number 71, to the odd ones. And then you continue number 73 to number 81, do the odd ones also, but don't need to graph. Just do them algebraically. Okay. Now let me show you first the first test from spring 19 that I mentioned before. I want to share that with you, where you can study from. This is my website. And then click on my name or my face. And then on my page, you go to the menu. Under teaching, there's a drop down, click previous teaching. And then on that previous teaching, I would like you to see Spring 19, Math 245. Now, if you don't see any files here, what you can do is you reload it, okay? Now, then let me show you the blank test. Your test one, this is supposed to be test one. This is supposed to be test one. That's a typo there. Your test one will look like this. Okay, I do not expect to have. Oh no, this is test two. This is test two. It is true. This is test two. What happened? Yeah, that's test two. Yeah, hold on. What happened? Did I save it incorrectly? Give me a second. Good thing I say, otherwise you study wrong thing. Oh shoot, what happened? Give me a second. I need to fix it right away. Or did I save it incorrectly last time? Yeah, I guess. Give me a second. I need to update it right away. So looking at my website. Show you this. Give me a second. Yeah, wait for me. Okay, wait for me. Maybe 2 minutes should be the most. Okay. Now you can see my inner loop. Should be okay. Spring 19 test one. Reload. Okay. Yeah, this is what your test one should look like. I don't expect to change it dramatically. Of course, you should not expect the same question. I usually ask, of course, different questions, but the things that you need to keep in mind is the following. Let me enlarge this. You are looking at my old test, right? Okay. You see here, number 1, 14 points, 4, 6, 4. Now, I don't think I will give you such a big number of points for these simple questions anymore. Okay, but what I want to say is the following. This number 1 consists of A, B, C, right? Okay, consists of A, B, C. So question A, 4 points, question B, 6 points, question C, 4 points. When you study, time yourself. Okay, of course, you need to learn to do it right first. Okay, so you may need to do the same questions, the same problem set, maybe 3 times, 4 times. So the first one or second times, you focus on doing things right. And then after that, you time yourself. Okay, how many minutes should you do a problem with 4 points? The rule is the number of points subtracted by 1. The number of points subtracted by 1. So question 1A, 4 points, we should do it in at most 3 minutes. In at most 3 minutes. Well, if you can do it in 1 minute, that's great. Okay, as long as it's right though. Okay, if you do it in 3 minutes, you are fine. Okay, but if you do it in more than 3 minutes, then ask yourself what slows you down. Okay, so use these numbers here, the number of points for that question, to help you, guide you if you are doing okay or not. Okay, because one way to know if you are prepared or not is you are prepared time-wise also, right? You can do the problems, you can finish the problem in a timely manner. Not only doing it right, but also in timely manner. In other words, I don't give you this, for these 4 pages here, I don't give you like 3 hours for this. No, I give you only 2 hours. And in your test, this test I give them in class, so I don't give I give them basically enough space. For your test later on, I may expand it to be like around 6 pages, maybe 7 pages. Okay, but the number of questions, it will be similar questions. Okay, it will be similar questions. In other words, I give you more space such that it seems like you have more pages, but that's because I give you more space to write on. Okay, now if you see, oh, Thomas, you only give us 2 hours for 7 pages test. Well, but that 7 pages, actually a lot of blank space, right? Okay, so don't be afraid with the number of pages. What I need you to practice during this weekend is like doing it right. That's first. Second, do it at the proper time. Okay, that's for my old test 1. Of course, using this spring 19 test 1, then you go back to my old test. You may want to take a look at my test under Santa Monica College. Okay, and look for similar questions. Let's say test 1, math 26, which is college algebra at Santa Monica, right? Okay, you will see question number 1, question number 2, question number 3 are the same. Not 4, not 5, not 6, not 7. Okay, they have different textbook. Okay, so they look different at first, but then their test 2 may suddenly looks like yours. Okay, their test 2 and your test 2 actually quite similar though. Okay, so try to dig in further if you want, but at least study from that spring 19 one first. Okay, any questions for now? Okay, nothing. Let me go back to my notes. I will go on with 1.8. Now 1.8 consists of 2 parts, but they are actually very, very similar. 1.8 is nonlinear inequality. To be more precise, 1.8 part A is polynomial inequality. And the second part is rational inequality. Now, every time you deal with polynomial or rational inequality, I need to show the work, not only to do it, but you need to show it. You need to show what I call three-step procedure. Now, what are these three steps procedure? The first one is finding critical numbers. Critical numbers. Second, construct the sign graph. And the third one, summarize the solution. Okay, every polynomial inequality should be done in these three steps. Okay, example 1. Solve x squared minus x minus 6 less than 0. Now, before you start the critical number process, set one side equals 0 first. One side has to be 0 first. Now, once one side equals to 0, then you can start step 1. Step 1, critical numbers. Now, how to find the critical numbers? You copy that inequality, but set it equals to 0 instead of less than 0. Okay, basically you change that into an equation. Okay, you change that to an equation and then solve it. In this case, you solve it by factoring. So x equals to 3, x equals to -2. Now let me know if I'm too fast, because I need you to be really strong with the structure. Really strong with the structure. Second, sign graph. What I will do is I will apply these numbers on a number line. Okay, -2, let's say here, and 3, let's say here. Now, from number 1, we saw that this x equals to 3 and x equals to -2 are the numbers that make it equals to 0. Make the expression to be equals to 0. So if the bottom is the x value, the top is the y value. Okay. Now, why do we call these 3 and -2 critical numbers? They are critical because if there is any change of sign, positive becomes negative, negative becomes positive, then it must happen at the critical number. At a critical number. That's why we call that critical number. Okay. Now, I'm not saying that if you have a critical number, the sign must change. No. A critical number does not imply the sign have to change, but It just say that if any change happen, it must happen at those numbers. Okay. Now, in other words, if you plug in any numbers here, if you use any numbers in the same interval and you plug that into the expression here, okay, of course they come up with different values, right? But all of them must be positive or all of them must be negative. All of them the same sign. Okay, all of them the same sign. Now, the same thing too, if you pick any numbers, for example, here, right? Let's say x equals to -1, or x equals to 0, or x equals to 2, right? And you plug into this expression here, okay? Even though the value must be the same, all of them must have the same sign. All of them positive or all of them negative. Okay? Now, likewise, if you pick any numbers on this side here, even though the value may be the same when you plug them in the expression, however, they must have the same sign. Okay? Okay. Now, in other words, in this interval here, there's no critical number. In this interval here, there's no critical number. Because there's no critical number, you do not expect, we should not have the sign change from positive becomes negative. All of them must be all positive or all of them must be negative. Okay. Now, after all, what do we mean by calling a number a critical number? You call somebody is critical. You say Thomas is critical. I mean, even in real life, right? When you say, oh, Thomas is critical right now, you know what it means. It means I'm about to change from being alive to being dead. Right? Okay. When you say you have a critical moment, like for example, one of my critical moments is when I get married, right? That's a critical moment. Why? Because I may have a sudden change of behavior before and after get married. Okay, before I get married, I live for myself, right? So I live the way I want it, right? Okay, but once I get married, I need to be considered with my wife, right? I want to do something crazy. I want to go to casino. I need to remember that I have a wife and who at least she won't be happy if I go to casino. You see? Now, another critical moment, for example, when I have my son, and then when I have my girl. It just makes me different person. Okay, that's why you call that critical moment. Now, not all critical moments are bad though. Okay, critical moments are the ones that change you. Okay, so you must have your critical moment yourself. Okay, you must have your critical moments yourself. The moments that really challenge you to think more about your life. Do you want to be a better person, or do you decide to just slack off? Okay, and good thing is in our life we have a lot of critical moments. On the other hand, for the same reason, then if you don't have any critical moment between now and tomorrow, then your lifestyle will be the same between now and tomorrow. Don't you think so? Right? Okay. If your life suddenly, the way you think about yourself, about your life suddenly change between now and then, there must be some critical time in between now and then that change your mindset, right? Okay. Now coming back to this, algebra, okay, I just try to explain why they call that critical numbers. Okay, it's critical because if there's any change of sign, it must happen there. Okay, it doesn't imply, however, if you have a critical numbers, then there must be change of sign. No. It is possible the sign on the left-hand side here is the same to the right-hand side. It is possible. Okay, that's what we are going to check. Okay. Now then, next. Why do we want to, you say the sign graph plus minus, but why, Thomas? Why do you only care about plus minus? Well, because what we want to do is actually less than 0. Now, less than 0 means what? Means negative, right? Less than 0 means negative. That's right. Okay. So our solution later on will be the interval that gives us negative value. Okay, now the thing is, how do we decide which interval of these three intervals here give us negative value? Then we need to check one by one. Okay, now then I do the testing point. You pick any point on that interval. Let's say in this interval here, I will pick x equals to 0. Okay, can I pick x equals to 1, Thomas? Yes. Can I pick x equals to -1? Yes. Can I pick x equals to 7/8? Yes, but why? You like fraction that much? Okay, because you have that freedom to choose. You don't make a decision that make your life harder, right? I mean, that's true in real life, that's true in math. Okay, simply because you have that freedom doesn't mean you just use it without thinking, right? Because don't forget though, especially in America, in other places too, actually, okay, you have freedom to do what you want, but you don't have freedom from the consequence. Okay? When we say freedom in America, it doesn't imply freedom from the consequence of your choices. No, you cannot say I choose this thing, but I want the outcome other thing. No. Okay, you cannot say you don't want to study, but you choose not to study, but you want to get the free diploma. No, it doesn't work that way. Okay, it doesn't work that way. Okay, so because you have the freedom to choose which number, and choose that wisely though. Okay, and it's actually not too hard to make that kind of choice. Just please be reasonable. Do not choose, for example, an ugly fraction, 7/13. But Thomas, 7/13 will work, right? Yeah, but why? Okay, yeah. Be reasonable to yourself. Okay, I mean, if you choose 7/13 to check, go for it. I mean, that's what you want to do. Okay, but don't complain later on if it's too hard to do. That's one. Second, don't complain if you don't have enough time. Okay, you make bad choices. Be ready with the consequence. Okay, and when you get the consequence, don't say, "Well, I didn't know that's what will happen." Well, before you make a decision, think. Okay, that's what your brain for. In fact, people who told me that, Thomas, I didn't think that way, or I don't have that brain power, you are degrading yourself. Okay, when I say you should think, that's because I believe you can do so. Okay, respect yourself. Okay, now coming back here, suddenly I use critical numbers to explain critical moments in life, and sign graph, testing points as how you make decision, huh? Yeah, we can learn a lot of life lesson from math. In fact, to be honest with you, it's actually the other way around. You can use life experience in doing your math. Okay, so between -2 to 3, what number you want to use? I think I would choose x equals to 0. So when x equals to 0, I plug that in here and here. Okay, and we don't worry about the value, we just worry about the sign. Okay, we just worry about the sign. Is it positive or negative? So let me plug that into 0 minus 3, 0 plus 2. 0 minus 3 is negative, 0 plus 2 is positive. So negative times positive is negative. Oops, I say negative, I write positive. Can you follow me so far?
I kind of don't understand what you're saying.
I'm saying you pick a number from this interval. Any number is fine. Okay, and then plug this number into the factorized form. So I plug in x equals 0, 0 minus 3, 0 plus 2. Now 0 minus 3 is negative, 0 plus 2 is positive. Now negative times positive is negative. Thomas, what happens if I don't choose x equals to 0? How do you know I need to choose x equals 0? No, I didn't say you have to choose x equals 0. I say just choose something from that interval. Okay, so what happens if I choose x equals to 1? Then you try to do it then. Okay, but let's say I do it for you. Okay, let's say you choose x equals to 1. Now 1 minus 3 times 1 plus 2, right? 1 minus 3 is negative, 1 plus 2 is positive. You see, the product still negative. You see, right? Okay. Why? Because between 0 and 1, there's no critical numbers. So you do not expect there's a change of sign in between those. You see what I mean? Okay. So Thomas, how do I decide? Well, experience. Okay. Practice. You need to do problems at home. Okay. Nobody learn math by just looking at that. You need to do it. Okay. You need to do it. I see a chat message coming in. So we need to test every interval. Yes, for at least for now, that's how we will do it. Okay. Later on, I think on Tuesday, then I will show you there's a little shortcut that you may be able to do. Now on this interval, let's say I pick x equals to 5. Can I use 15, Thomas? Yes. Can I use 10? Yes. Can I use pi, which is 3.14? Yes. Okay, but when x equals to 5, I will get 5 minus 3, which is positive, times 5 plus 2, which is positive. Notice that I didn't really compute 2 times 7. Of course, I can compute that 2 times 7, right? But what I really care is just about, is it positive or negative? Okay, this will be positive. And likewise here, you will see x equals to, let's say I pick x equals to negative 5. So negative 5 minus 3 times negative 5 plus 2. That would be negative times negative, that's positive. Okay, now you will see later on that I will not write this anymore. Okay, I will just do it mentally. Okay, in other words, this part here is okay not to show. Okay, eventually you will see that even this part here is also okay not to show. Okay, but I will show you first, at least for today. Okay, I will show you first, at least for today, what are the testing numbers. Okay, what are the testing numbers, and then what's the sign. Okay, now once we get the plus minus for each interval, then I go on summarizing it. We need the negative part, right? The solution will be, we need the negative part. Do we include 0 or not? Do we include 0 or not? Not including 0, right? So it will be just the negative part, not including the 0. So the solution will be between parentheses negative 2 up to 3 parentheses. Now that implies any x between negative 2 to 3 that you plug into here, it will make this inequality a true statement. Now from here, I will do maybe 2 more questions or 3 more questions. Okay, let's see, for example, problems in the book number 20. Number 20, x squared plus 2x greater than 3. Now keep in mind that the other side has to be 0 because we will check the plus minus later on. Okay, now to make it equals to 0, I subtract 3 both sides. Okay, and then once you're done, start the procedure, the 3-step procedure. Step 1, critical numbers. And I need you to write this. I want you to write this explicitly. Okay, write this explicitly. Write this explicitly. Number it, and tell yourself what you are doing. But Thomas, I can just do this problem without showing those kind of works. Trust me, eventually you will get it wrong. Okay, it's just about time. Okay, show me somebody who can do it without what I do here, and I will show that person a question that person will mess up so badly. Okay, don't challenge me on that one. Okay, I have enough of that. Okay, sounds like I'm mad, huh? No, I'm not mad with you. I'm mad with those students who think they're so smart, and in the end they drop the class simply because of their arrogance. Okay, and it's like this. They try to show off in class. Thomas, do I have to show it to you? Okay, I don't need to do it with like that. And then when they get it wrong, they get so embarrassed they don't even can face me anymore. They end up dropping the class. What for? Right? It's not that I am happy that you are wrong. No, that's not my point. Okay, I'm not happy that you are wrong. But why do you even need to question my experience? Okay, okay, no need. In fact, our textbook doing it that way. Other textbook doing it that way. Pre-calculus textbook doing it that way. Every textbook doing it this way. They just don't say it explicitly. Okay. Now, if somebody told you that you don't need to do it that way, basically you're learning it from somebody who don't actually read the textbook. And trust me, that person get it right by chance only. If you start living your life up to chance, then the chance is eventually you will drop down, right? No, that's not a good idea though. Okay, especially if you are going to business major. Yeah, we have some, we take risks when you do business. We take risks, but we try to take calculated risk. Okay, we try to take calculated risk. So show me this step, please, please, please show me this step. Okay, show me this step. I say it for you. I say it for you. I have a student actually in spring 19 challenge me this way. Thomas, I will show you I can do this without showing that step 1, 2, 3, and I will get it right. Guess what? Out of 3 questions, that person missed the last 2. That person only get the first one right. And that first one happened to be linear inequality, in which you don't need to do it in three steps, right? Okay, polynomial inequality is the time you need to show these 3 steps. Okay, set one side equals to 0. Okay, once that inequality has 0 on one side, then you find the critical numbers. For now, we rely on factoring, but please be aware that there's a chance it's not factorable, but you still need to solve it. Okay, either you do it by completing the square or by formula. Once you get the critical number, you do the sign graph. Oh, by the way, you know I cannot show you the old tests, right, from spring 19. Okay, that person knew that she didn't do well in that test 2, and then she didn't pick up her test 2, and then she dropped class. So I still have her test 2. Okay, but the thing is I cannot show it to you though, right? I cannot show it to you, just to show you what happened with her. And then on her paper, the things that she make mistake, I say, told you. What do you feel if I say it that way? Get pissed off, right? Okay. If I don't say anything when you make mistake, it means I don't care about you anymore. But the reason I say this to her at that time is because I want to give her critical moment. Hopefully she can change. Too bad she decided to drop the class without talking to me. Okay, even before she had this. Okay, but I really wanted to talk to her, saying that, hey, you know what? You can do better. The fact that you think that you can do it without doing these steps, it means you have enough confidence. The problem is you don't have enough structure. Okay? Yeah. You may have a very good skill in math, but still don't forget the procedure though. Okay? Okay, do the sign graph. So draw the number line. put the critical numbers, -3 and then 1. Those are the zeros, right? And then I pick testing points, testing numbers. Let's say x equals to 0. Now, when x equals to 0, is it positive or negative? When you plug in here, the first factor is positive or negative? Zero plus 3 is positive, right? And the second factor, 0 minus 1, is negative. So the product is negative. Now do the same with the testing number, testing point that you use here. Let's say I have x equals to 5. 5 plus 3 is positive 8. 5 minus 1 is positive 4. Positive times positive is positive. Pick, let's say x equals to -10. -10 plus 3 is -7. -10 minus 1 is -11. Negative times negative is positive. So I need the one greater than 0. So I need the positive branch, not including 0. So the solution will be -infinity up to -3 parentheses union 1 to infinity. Okay. Now, if the inequality includes equal sign, it means your answer should include the ones, the x that make it 0. Let's say I pick question number 28. I pick question number 28. 2x cubed plus 13x squared minus 8x minus 46 greater equals to 6. Set one side equals 0 first. So I move the 6 to this side. And then you find the critical numbers. Okay, by setting it equals to 0. Because there are 4 terms here, let me do the factorization by grouping. X squared 2x plus 13 minus 4 times 2x plus 13 equals 0. So the common factor now is 2x plus 13, x squared minus 4. Oh, I can go further. 2x plus 13, x plus 4, x minus 4 equals 0. So the critical numbers are -13 over 2, -4, next, I do the sign graph. Now make sure when you put in your critical numbers, you really put it correctly on the number line, in the sense that -13 over 2 is -6.5. It should be on the left-hand side of -4. And +4 should be on the right-hand side of -4. Okay. You are right, 2 and negative 2. I bet. Thank you. Oh, that's almost become a disaster. Yeah, thank you very much. Now then from there, I pick the testing numbers. Okay, let me pick, let's say, here x equals to 0. Yeah, x is equals to 0 is between negative 2 and 2, right? When x equals 0, you plug that into this factor form. You plug that into the factor form. That will be positive, positive, negative. Right? Positive, positive, negative. So it becomes what? Negative. Okay. And then let's say I pick x equals to 5 here. When x equals to 5, it will be positive, positive, positive. All of them positive. So it must be positive here. Negative 2 and negative 6.5. So pick a number in between. Can I use negative 3? Or negative 4, right? Negative 3 or negative 4. Let me use negative 3. So when I put negative 3 here, that's negative 6 plus 13, that's positive, right? For negative 3 here, that's negative. That's negative. Okay, I write it down. That's positive times negative times negative. So that's positive. And then here, let's say I choose x equals to negative 10. Negative 20 plus 13, that's negative. 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 That's negative. 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 The product is negative. Step 3, the summary. So what do we need? Do we need positive or negative? We need greater than 0. In fact, greater equals to 0. So positive and 0. Positive and 0. Positive and 0. So the summary will be, the solution will be from negative 13 over 2 included up to negative 2 included, union, included 2 up to infinity. Yes?
Oh yeah, Professor. Look, okay, I kind of don't get how you bracketed. How come you didn't bracket -2 and +2?
Why I don't bracket?
Yeah,
Yeah. That's a bracket there.
No.
I use bracket there.
Huh?
I use bracket on my negative 2 and 2.
No, I'm talking about, okay, so you know how you put, like, it's a bracket negative 13 over 2 and a negative 2 and a negative 2 bracket? How come you didn't, like, why then the brackets together? Like, why isn't it the bracket -2, then 2, then a closed bracket?
Well, because you want the positive part. From this inequality here, you want the positive, greater than 0. Right? Now then on the number line, you see which region, which interval give you positive. This one here and this one here. Now between -2 and 2, it gives you negative. So that should not be part of the solution.
Okay.
Right?
Yes, sir.
Yeah, so between -2 and 2, it will give you negative. That's not what you want. Okay, how do we know we want positive or negative? From the original question, is it greater than or less than 0? Okay, so in the question we have here, in our example one, we want less than 0. That's why I picked the negative part. Okay, not the positive part. Now in example 2, we want greater than 0. That's why I take the positive part. Okay, the positive part, -infinity to -3, 1 to infinity, 1 to infinity. Okay, now let me go on. In our examples that I did here, example 1, number 20, and number 28, all of them have the sign alternates, like plus, minus, like minus, plus, minus, plus, right? Keep on alternating. But that's not always the case. That's not always the case. That's why you need to do testing point. At least for now, please do the testing point. Now, suppose, for example, I do number 36. Number 36, we have x to the 4th, x minus 3 less than equals to 0. It's already 0 on one side, so I can start with the critical numbers right away. So x to the 4th, x minus 3 equals to 0, x equals to 0, x equals to 3. Now when I do the sign graph, we have 0, we have 3. Both of them make the expression equals to 0. Now then I will do testing point. Let's say here x equals to 1. When x equals to 1, 1 to the 4, that's positive. That's basically positive to the power of 4 times negative. That's negative. Okay, let's say when I get x equals to 5. 5, which is positive to the 4th. 5 minus 3 is positive 2, so it's positive. All of them positive. This is positive. Now, can you check what will this be? Let's say I pick x equals to negative 2. Will that be positive or negative? You see there will be negative to the 4th times negative, right? So it becomes positive times negative, that's negative. Okay. Now then, let's go on. Step 3, what is our conclusion? So I need something to be less than 0. Less than 0 refers to the negative parts, right? And including 0. So I will include this, I will also include that. Okay, so the solution will be basically negative infinity up to 3. Notice that we really take care of the inequality sign at step 3. Okay, in step 1 and 2, we only worry about this side. Once this guy is 0, then you just worry about this. You come back, take care of the inequality sign in step 3. Okay. Now, let me emphasize what I said earlier by doing very similar problem. For example, let's say I have x to the 4th times x minus 3 greater equals to 0. Compare that with this. Compare that with this. The only difference is the inequality sign, right? The only difference is the inequality sign. Now, I said earlier, the inequality sign only come into play in our last step 3. In other words, because the expression on the left and on the right are exactly the same, then the critical numbers will be the same. The critical numbers will be the same. X equals to 0, x equals to 3. Second, the sign graph will also be the same. Will also be the same. It is the conclusion that is different. So, what's the conclusion? From the critical numbers are 0 and 3. The sign here is positive. This is negative. This is negative. Now, what we need is the positive part and 0. The positive part and 0. But this is also 0. Positive part and 0. So this will be a point 0 union 3 to infinity. Okay. Now, but at least from these two examples here, you notice that on the sign graph, you notice that the adjacent signs may not be alternative. Okay, notice that the one these two here, okay, the sign does not change. The sign does not change. So I hope that answers the question. If you have any, Thomas, does the sign always change? Plus becomes minus, minus becomes plus on different sides of a critical number? The answer is no, not always. Next. Rational inequality. The way we do this is similar, except that we have critical numbers that come from undefined. Let's say, for example, if we need to solve x plus 2 over x squared minus x minus 6 greater equals to 0. The principle is exactly the same. The principle is exactly the same. Before you start working on your critical numbers, the other side has to be 0. Okay, the other side has to be 0. So one side already 0, then you start critical numbers. Oh, one thing I need to warn you ahead. One thing I need to warn you ahead. Do not multiply by LCD. Let's say for example, if you have x plus 1 over x minus 3 less than equals to 4. Okay, now multiplying by LCD x minus 3 was allowed if you have equality, if you have an equation, but it is not allowed if you have inequality. Okay? Not allowed to multiply by an expression. Okay. If you multiply all by 3, that's okay. Okay, like if you multiply by a constant, that's okay. Okay. The problem with an expression is because an expression which may be positive and also maybe negative. Okay. Remember, for inequality, when you multiply by a negative number, you need to reverse the inequality sign, right? Okay, but if you multiply by a positive number, you don't need to reverse inequality sign. Now, the thing is, x minus 3 is unknown if it is positive or negative. Depends on the value of your x, right? Okay, that's why multiplying by the LCD is not a correct way, because you don't know if that expression, in this case x minus 3, is positive or negative. Therefore, you don't know if you need to reverse the inequality sign or not. Okay, so that's not a correct way. Do not multiply by the LCD. But trust me, during the test, somebody still think it will be just that easy. That's basically students who don't study. Okay, because if you study, even if you do that, if you study, you will check your work with the back of the book and you will see that it's wrong. Okay, so I dare enough say those students who did this in your test simply didn't study. Not only not studying from me, you don't even study from the book. Okay, but I studied, Thomas. BS, that's lying. Because if you did study, you must have seen your mistake. Okay? No. I wish I can say it nicely. Okay, but the thing is, when I say it nicely, people don't take it. I don't grab their attention. I need to say it this way. Then they start thinking. Okay, and I hope it doesn't happen with you. No. If saying it harsh way prevent you from making that mistake, so be it. I don't try to be a nice teacher. I try to be a teacher at which you can do well in math. That's my purpose. Okay, if you don't like me as a person, fine. You never see me anyway, except by Zoom, right? Okay, but later on, when you do well in your calculus for business, right? Okay, then you will be happy. Don't you think so? Okay, right? And I will be happy too, regardless you like me or not. Okay, yeah. As a teacher, I need to prevent my personality to come into interfere with my teaching. It's like my personal being of I want my students to like me too. Okay, but that should not be my priority. Okay, my priority will be that you pass this class and you are ready for the next class. Okay, and I consider myself successful if that's what you have. Okay, I consider myself successful if that's what you have. Okay, let me continue. So here I get my critical numbers, set it equal, let me factor it at the same time, -3. Oh shoot, no. Let me make it +6 here. Okay, let me make it +6. Can I make it +6? No, I cannot make it +5, x squared minus 5x plus 6. I will show you what's the problem in the next example if I keep it x squared minus x minus 6. So from here, we then have the critical numbers x equals to -2. I'm sorry, it should be equal to 0 here. Okay, yeah, x equals to -2 is a critical number. It will make it 0. Okay, but x equals to 3, x equals to 2 are also critical numbers because it will make it undefined. Okay, it will make it undefined. Now, step 2, sign graph. We get -2 that make it 0, 2 that make it undefined, 3 that make it undefined. Okay, now then from here we will do the same procedure, testing numbers. Let's say I have x equals to 0. When x equals to 0, plug that in here. When x equals to 0, the numerator is +2. The denominator on the left-hand side is -3. And denominator on the right-hand side also is -2, also negative. So the product and quotient altogether give us positive here. Let's pick a number here in between. Let's say x equals to 2.5. So 2.5 plus 2, that's positive, over 2.5 minus 3, that's negative. 2.5 minus 2, that's positive. What will that be? Positive or negative?
Negative.
That will be negative. Okay, how about when I pick a number here? X equals to 5, let's say. And that will be positive over positive, positive. It's all positive. But when x equals to -5, -5 plus 2 is negative. -5 minus 3, that's negative. -5 minus 2, that's also here. How about the summary? So step 3, what do I need? I need greater or equals to 0, positive or 0. So the one that is positive, this is the positive, this is the positive, and this gives us 0. So the solution will be, bracket -2 up to 2, parentheses. Notice that I never include undefined, right? Okay. In this case, we want 0, but we never want undefined. Undefined is the one who's like, they don't know what they're doing. Okay. Yeah, that's why we call it undefined. Okay, and then union. Then union. Union what? Can you help? Union parentheses 3 to infinity. Okay. Let me do one last problem. Yeah, let me do one last problem. Number 50. 1 over x greater equals to 1 over x plus 3. Remember, do not multiply by the LCD. Remember, do not multiply by the LCD. In fact, what we will do is to move one side such that the other side is 0. So let me decide to move this to the left. Now, and then simplify. We learned how to simplify fraction before, right? In fact, I believe this was part of your homework problem. So this will be x plus 3 minus x over x times x plus 3 greater equals to 0. That is x 3 over x times x plus 3 greater equals to 0. So I set one side to be 0 and simplify the other side. Now then I start the procedure. Critical numbers.
Excuse me, sir.
Uh-huh.
Wait, did you multiply x plus 3 to both sides?
No. I did LCD, so once I have this here, then I see all the LCD is x times x plus 3. X times x plus 3. Now
But
then,
I thought the whole rule was to not use the LCD.
what? What repeat it again?
I just said I thought the whole rule was to not multiply with the LCD.
I didn't multiply by the LCD. I find the LCD, but I didn't multiply the inequality by the LCD. I didn't multiply the inequality by the LCD. But doesn't mean we don't look for the LCD. I look for LCD, but I didn't multiply by the LCD. I just simplify this side here.
Okay, I got you. Thank you.
Okay. Now then, the critical numbers 3 over x times x plus 3 greater equal to 0 implies the critical numbers. No critical number from the top, but we have critical numbers from the bottom. So the sign graph. We have, oh, be careful, negative 3 on the left hand side. To 0. And both of them will make the expression becomes undefined. Then I do testing point. Let's say I pick x equals to 1. Can you guess or can you try what will the sign here be? Positive, 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 right? So it will be positive. when x equals to -2, let's say, what will the sign be? Positive, negative, positive. This is positive. I say positive. This is negative, and you will see the one here. Let's say I check x equals to -5. I will see this is positive. Now the thing is, what I need is this expression that I use. I need the positive or equals to 0. Positive or equals to 0. So the final answer will be -infinity up to -3 union 0 to infinity. Okay. Now I do not expect you to do all the suggested homework right away, but I do expect you to do at least every other odd. Okay, so from this 1.8, I would like you to do number 13 to number 35, every other odd. And then number 41 to number 53, also every other odd. During this weekend, I want you to study for your test, especially. Okay, I want you to study for your test, especially. But then I need you to do every other odd during this weekend. And then later on, do the other odd. After test 1, which is basically next Thursday. Okay. Yeah. So what do we do on Tuesday next this coming week? On Tuesday, I will do maybe one more problem from 1.8, and then I go on to chapter 2. Now, the beginning of chapter 2 is actually things that we already covered before. Okay, but we will see the real college algebra there. What we have done so far in these 5 weeks, actually just going over what we learned in intermediate algebra. Okay, that's for today, and see you then on Tuesday next week.